Difficulty hearing speech in noisy backgrounds, also known as the cocktail party problem, is a principal consequence of age-related hearing loss, which affects 1 in 3 older adults. Growing evidence suggests that neuroplasticity induced by training can be an effective treatment for deficits connected with age-related hearing loss. One such treatment for promoting neuroplasticity is exposure to the Augmented Acoustic Environment, or AAE. We know that the AAE has been shown to improve auditory function in a developmental hearing-impaired mouse model. However, a chief complaint of the elderly is the inability to hear in a noisy background. Thus, we employed a novel AAE consisting of signals embedded in background noise to simulate real-world noisy environments. These tones were presented at various signal-to-noise ratios above the noise floor, shown in figures 1 and 2. Old mice were exposed to the AAE over a 2-month period, and then behavioral and physiological responses to a novel signal and noise stimuli were compared to those of an unexposed control group of similar ages. See figures 3 through 6 for data acquisition schematics and timeline. We found that the signal and noise AAE resulted in a generalizable improvement in behavioral signal and noise detection across the frequency domain, showing significant improvements from baseline to 2 months post at all testing frequency. This is shown in figures 7A through C. This amelioration was not seen in the non-AAE exposed control group. Both groups showed comparable sensory motor gating processing as evidenced by startle input-output functions and auditory brainstem response threshold shifts. This is shown in figures 7D through E. To determine the neural correlates of signal and noise processing in the inferior colliculus, the filter properties of neurons were determined via excitatory frequency response area measurements. This is shown in figure 8A. Spiking properties of these neurons are represented by peristimulus time histograms, where the green window represents the onset of the tone above the background noise, and the red window indicates the steady-state baseline window. Tone and noise detection was classified by comparing the number of spikes in the green window versus red window and running the Wilcoxon ranked sum test to assess for a significant difference. Overall, electrophysiological response characteristics in the inferior colliculus improved, showing a significant increase in firing rates of the tone and noise stimuli in the AAE group compared to the control group. This is shown in figures 9A through B. A tone-ectopic shift in neurons responsible for auditory processing resulted in finer frequency selectivity, which suggests active neuroplasticity in the auditory midbrain, shown in figure 9C. In summary, our data demonstrates that passive exposure to a signal and noise AAE improves signal and noise detection in aged mice and suggests active plasticity in the aged auditory system. These findings also suggest that the acoustic startle reflex, coupled with the signal and noise environment, may be a useful tool in assessing the efficacy of a potential treatment for age-related hearing loss. Thank you.